Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 1, Lesson 4. We're going to continue with our lessons on equations, and we're going to add a little wrinkle to it with special cases. There are situations where you can have infinite solutions or no solution to an equation. And up until now, we've done it where we've had one solution. So our objectives today is I can solve multi-step equations easily and correctly. So you should be feeling pretty comfortable with this at this point. You know what a no solution equation is when you solve it, and you know what an infinite solution equation is when you solve it. So how do you tell the difference between these, and how does it compare to, solving it regularly? So let's get into this. My one solution, this is what we've been doing, up until now. So there is only one solution. And so when you solve it, it looks something like this. So I'm going to, I've got 2b minus 9 equals 3 plus 5b. I move my 5b over. And that gives me negative 3b minus 9 equals 3. And that, zeroed out. And I move my 9 over. So I'm adding 9 to both sides. And so I get negative 3b equals 12. And I divide by negative 3 on both sides. And so I end up with v equals 12 divided by negative 3. So v equals negative 4. I get one clear answer that is the solution that will make this equation true. But that doesn't always happen. So now we're going to introduce, the first kind of special equations where we have no solution. And so if there is no solution, there is, no solution for these type ones. And so no number, it doesn't matter what the number is, no number can be substituted for x to make the equation true. So nothing is going to make this work. Now, when you visually inspect this equation, you should see something kind of interesting here. We have an x on this side, and we have an x on this side, and a 4, and a minus 5. This is already looking a little weird and a little suspect, but let's go ahead and solve this, and let's see what happens. So I got 4 plus x equals x minus 5. So I'm solving it just like how, I started solving that one solution one that I just did. And I see something happen here. X minus x, that's going to cancel out. I bring down my 4, just like normal. But I look over here and I get x minus x. That also cancels out. So that's kind of weird. And so I bring down negative 5. And we get this situation where it says 4 equals negative 5. Well, no. I mean, that is false. Okay. 4 is not going to equal negative 5. 4 equals 4. That's the only choice available. So no matter, it's when we get this false statement, no matter what value you tried to plug in for x, no value will make it true. So when you get this false statement like this, there is no solution. Nothing will make it work. All right. Well, if we have a situation where we have one solution and we have a situation where we have no solutions, it makes sense and logical that we could have infinite solutions. Well, what does that look like when we go and solve it? So this infinite solutions is where all possible values are a solution. It literally doesn't matter at all what I put in for my x. It will work and make a true statement. So how does that look when we're solving it? I'm going to rewrite my equation so I can just look at everything as I'm writing it out. Okay, so I'm gonna group my like terms here. So I've got, this x and this plus 8x. I'm gonna go ahead and group those. So we got 9x plus 4 equals 9x plus 4. And already this is looking like a true statement. 9x plus 4 equals 9x plus 4. Yeah, I mean, we would say that's a true statement. I'm going to go ahead and move my x over. And you see the weird situation kind of shaping up here. 9x minus 9x, that cancels out. We get a 4 equals 9x minus 9x, that cancels out. And we bring down that 4. So when everything makes it to the end, you get this true statement. 4 equals 4. This is true. It is always true. It doesn't matter what you put in for these x's. Anything you put in there, any number in the whole world will make that true. And so this is infinite solutions. And then you can even use your fun symbol, your infinite symbol, which of course, mine always looks a little interesting, and it's okay if yours looks a little interesting too. Okay, so we're going to look at example 1, and this isn't readily standing out to me as any particular way. So there's going to be one solution mixed in here with no solution and infinite solutions, and we're just going to go along until we get to the end and we see, what did we end up with? So we're going to solve all of these in the same exact way you've been solving equations so far in your whole existence. So we're going to do, 6 times 1, that's 6. So we're going to do the distributive property. 6 times negative 3x is going to give me negative 18x equals negative 36 minus 4x. I'm going to go ahead and get my x's together. So I'm going to add 4x to this side and add 4x to this side. So I bring down my 6 and I get 6 negative 18x plus 4x is going to give you minus 14x. I bring down my negative 36 minus 4x plus 4x, that cancels out. Okay, we got to clean it up a little bit more. So let's get, our numbers without the variable together. So we got a positive 6 on this side. I'm going to subtract it from both sides. So I get negative 14x equals negative 42. I'm going to divide by my coefficient. And when that happens, we're going to get x equals 3. And so that's a one solution one, like all the equations that you have solved in your existence up until now. Alrighty, let's do this next one. We are going to kind of visually look at this. Nothing really stands out to me so far. I'm going to write this down so I can pay attention to all the different parts to this equation. Okay, I see I've got the distributive property, so I'm going to start there. So I get 6 times x, that's going to give me 6x. 6 times negative 6 is going to give me negative 36 plus 4 equals negative 32 plus 6x. I see that I have some things I can simplify here on the left side, and that's what I'm going to do. So I've got 6x minus 36 plus 4 is going to give me negative 32 equals negative 32 plus 6x. And you start to get a feeling like, something's happening with this equation, and it's probably, not a one step. Let's go and get our x's grouped together. So I'm going to subtract 6x from the right to make my x, drop out. And if I subtract 6x over here, I see something is occurring. So 6x minus 6x, that cancels. I can bring down my negative 32 equals negative 32. 6x minus 6x, that's going to drop out. So my x's all dropped out once I did all the simplification. And I end up with this statement here. And this statement is telling me, it's a true statement. It's telling me that we're going to have infinite solutions. It does not matter what I put in for my x. I could pick any number in the entire world and it will work. It will it'll be a solution. Okay, so we've got example number 3, and I'm just going to go and write that over again. So I can see all my components as I write it. I see I've got parentheses, so I know I've got to distribute as my first step. So I'm going to do 2 times x, that gives me 2x. 2 times negative 3 is going to give me negative 6 equals negative 2 plus 2x. And I can see something interesting shaping up. I've got 2 x's on both sides, and let's just go ahead and keep going. I'm going to take this 2x, it's positive 2x, so to get rid of it, I got to subtract 2x, and I'm going to subtract 2x from this side. And I get this interesting situation where I get 2x minus 2x, that cancels out. And I bring down this negative 6 equals, I bring down this negative 2, and my 2x minus 2x, that also cancels out. So I get this interesting situation where I get negative 6 equals negative 2, which is not ever going to be a true statement, right? This is a false statement. So when you get a situation like this, it means no solution. So I want you to take a moment and let's visually compare the 3 things that we've just done so that we can see how it is that it works out. So we go through all of our processes to get everything simplified, and on one solution, we get where x equals only one thing. If it is an infinite solution, when you get down to the bottom of it and you've gone through all your steps, you're going to get a true statement where 2 numbers will be equal to each other, and it'll be like, yeah, that's always a true statement. So that's infinite solutions. It doesn't matter what you put in here for these x's, it'll always work. But when it's no solution, by the time we've done all of our steps and it's no solution, any number in the whole world you put into this, it'll never work. It'll never be a solution. And so you're solving them all the same way, but what you end up with determines if it's one solution, infinite solutions, or no solutions. Alrighty, let's look at this next example here. I'm going to take all this and rewrite it, and we're just going to see what happens. We get 8 minus 8 times 1 plus 3x equals 23 minus x. Alrighty, so I can see that I've got my parentheses, so I know that I'm going to need to start with the distributive property. So I can just go ahead and write this 8 over again, and then I'm going to take my minus 8 and multiply by 1, and that's going to give me another, minus 8 there. And minus 8 times 3x is going to give me negative 24x equals 23 minus x. I can see that, things are, I can regroup some stuff. I can simplify some things. So I've got 8 minus 8 over here on this side. And so when I go to do that, I see 8 minus 8. That actually drops out, which is kind of cool. Negative 24x equals 23 minus x. I'm going to remove this x from here. And so I'm going to add x to both sides. Negative 24x plus x is going to give me negative 23x. equals, bring down that 23. So we got 23 at negative x plus x, that drops out. Okay. So now I've got a coefficient in front of my x. I can divide by negative 23. And I get x equals negative 1. So this is a one solution problem. Negative 1 is the only number that will make a true statement when you plug it in up here for these x's. Okay, we've got example number 5. And, kind of visually inspecting this here, let's go ahead and write this down. We have negative 17 plus 5x equals 5 times x minus 5 plus 8. Alrighty, I can see I have the distributive property on the right side, and so I can bring down my left side because there's nothing more I can simplify on my left yet. I'm going to simplify what's on the right. So I got 5 times x. 5 times negative 5 is minus 25 plus 8. I see something right away on the right side that I can simplify a little bit more. So that's what I'm going to do. So I can't do anything with my left side yet. I'm just going to go ahead and write that over again. Write my 5x over again. Negative 25 plus 8 is going to give me negative 17. All right, we have the makings of something interesting looking like right here. And some of you may already realize what this is when you see negative 17 and 5x and negative 17. But let's just go ahead and take it all the way to the end and see what we get. So I'm going to subtract my 5x so that I can get the x's removed from the right side. And you'll notice, okay, we got negative 17. 5x minus 5x, that cancels out. My equal sign. 5x minus 5x, that cancels out. And I bring down my negative 17. So I get this situation here. Negative 17 equals negative 17. And you're like, yes, that is a true statement. And so when we have a true statement, and notice there's no more x's in here. I mean, it's just negative 17 equals negative 17. It means nothing we put in here for the x will ever make a false statement. Every number that we can put in there in the entire universe will make a true statement. And so this is infinite solutions. Or you could also use your infinity symbol, and it's always a little interesting drawing your sideways 8. Mine always looks a little interesting. And like I said earlier, it's okay if yours looks a little weird too. Last but not least, my friends, example 6. What's happening with this bad boy? Okay, so let's solve this. I'm going to write this down over again. And I can already see, just looking at it, you can see something weird's going on because you have 8x and 8x on each side. And then you're left with 3 equals 27. Huh? Well, let's go ahead and solve that. Let's just, we're going to take the 8x away from the right. And we got to treat both sides the same. So I'm going to subtract it from both sides. 8x minus 8x, that drops out. So I bring down my 3. 8x minus 8x, that drops out. I bring down my 27. And you get the weird statement, 3 equals 27. That is never true. That is a false statement, right? That is never a true statement. 3 does not equal 27. And so that means that no matter what you plug in for x into that equation, there will never be a solution. No number in the entire universe is going to work to make that right. I hope that helps, guys. Until next time, bye.